Hi everyone, I am Madam Rosmaya. So in this video, we are going to discuss on radioactivity. So we are going to solve the two problems using the formula given here. So we have discussed this formula in the previous lesson. Okay. So the first formula, negative dn per dt equals to lambda n. So lambda is the decay constant, n is a number of atoms. This is rate of decay, and n equals to n naught e to the power of negative lambda t. A is activity, okay, A equals to a naught e to the power of negative lambda t, and then lambda decay constant equals to ln 2 per half-life. Okay, so the first question. A radioactive sample contains 15 grams of radon-222. It is estimated that this source emits 2.061 times 10 to the power of 18 alpha particles per second. Calculate the half-life of radon-222. Okay, so given mass of the sample, 15 grams, okay, dN by dt equals to 2.061 times 10 to the power of 18. Okay, number of atoms decay in per second. We are going to determine half-life. And then the formula we are going to use, because this is dn by dt, so equals to negative lambda n. Okay, lambda not given, but lambda can be related to half-life. So lambda equals to ln 2 per half-life. So lambda not given, so we need to calculate lambda first, decay constant. And then n also not given, so we can use the information from here, radon 222. Okay, so from radon 222. So that's me. We use Avogadro number. Okay, this 222 means 222 gram per mole. So 1 mole contain 6.02 times 10 to the power of 23 Avogadro number. Okay, atom. So means in mole, 15 grams in mole is 15 per 222 mole. Okay, so how we get this? This is 220 gram per mole. This is 15 grams. So we write this in mole. We can use ratio method. Okay, we can write like this, 222 gram, 1 mole. So for 15 gram, how many mole? So we use ratio, we get this one, 15 per 222 mole. Okay, now to get the number of atoms, n, so also we use ratio for these two. So 15 per 222 times 6.02 times 10 to the power of 23. So the answer is 4.02 times 10 to the power of 22 number of atoms. Okay, so this is n. Okay, next we are going to substitute here to get decay constant. Okay, so dn by dt is 2.01 times 10 to the power of 18. Okay, then decay constant and then the n. Okay, this n substitute into here. So we bring to the left side 2.061 times 10 to the power of 18 divided by 4.07 times 10 to the power of 22. So we get decay constant equals to 5.06 times 10 to the power of negative 5. So this is decay constant. Okay, next we are going to use this this equation, this formula. So we substitute into here the decay constant. Okay, so decay constant equals to ln 2 per half-life. So we cross multiply ln 2 divided by 5.06 times 10 to the power of negative 5, we get 13,698.56 seconds. Then we can convert to days, 0.16 days. Okay, so this is the answer for the half-life of radon 222. Okay, next question. We read first the question. The graph represents the decay of a sample of a radioactive isotope. Calculate the half-life. So this is graph of count rate per against times, times in minutes, and count rate is activity. Count rate is activity. So that's mean we use this equation, activity. A equals to a naught e to the power of negative lambda t. So to calculate half-life, so this lambda we can use decay constant equals to ln 2 per half-life. So we find decay constant first using this equation. So there are 2 points here. So we form two equations. Okay, the first one, we use 25,000 A. Okay, 25,000. A note not given, but later we can cancel out the A note. Then E to the power of negative lambda T. So the time taken here 12 minutes. Okay, for the second point here, we substitute into another, we form another equation. 16,000 equals to A naught E to the power of negative lambda, here 30, 30 minutes, substitute into here. Then we use ratio. Equation 1 divided by equation 2. So 25,000 divided by 16,000. Okay, right side, A naught E to the power of negative 12 lambda divided by A naught E to the power of negative 30 lambda. Okay, then we can simplify this equation. Cancel A naught. The 3 zeros here also cancel out. So 25 divided by 16 is 1.5625. And then the power here, negative 12 lambda, minus negative 30 lambda, we get 18 lambda. Okay, then we convert to log form. We use ln. Okay, ln 1.5625 equals to ln e to the power of negative 18, e to the power of 18 lambda, right? No negative. Okay, ln 1.5625 is 0.4463. And then ln e to the power of 18 lambda becomes 18 lambda. Okay, use log rule to convert this to this. Okay, then cross multiply 18 here, bring to the left side. Okay, then we get decay constant equals to 0.0248. Okay, now after we get the decay constant, we are going to use this equation. Decay constant equals to ln 2 per half life. Okay, so we substitute decay constant here. Okay, so becomes half life equals to ln 2 per 0.0248. So we get half life 28 minutes. So this is the answer. Okay, half life. Okay, so that's all for the video, and thank you for watching.